All right, so I started recording. We are going to have to go back a little bit to do today's lesson. Today's lesson is solving inequalities, and eventually, here's what we're going to get to. Don't draw this, just watch. I want you to understand what we're going to do. Eventually, what we're going to have to do is I'm going to have an inequality, and I'm going to graph it, and that's what an inequality looks like. And maybe it's this side of the line. If you don't remember how to graph them, I'm going to go over it. Maybe this side line is the true side. Then we're going to have another inequality, because this is going to be systems of inequalities. So we're going to have another one that looks like this. And maybe it is this side. And then maybe we'll have a final one that goes like this. And it's all this side. And so hopefully you can see kind of where my colors all mixed. This area right here, that triangle, would be the solution for all three of them. That's what we're going to eventually get to. But before we get to that, let's just go over some stuff you should come in from Algebra 1 with. I don't expect you to be proficient at it like you need to be. That's why I'm going over it. So let's just talk about graphing, linear, and then back to inequalities, because it all kind of builds on itself. Like we've said, the problem with Algebra 2 is it uses everything that you've ever done in the past. And a lot of times we're not like really the way where we need to be at in the past. So that's why I review it so much. So first thing we should do is let's review just graphing linear, because it's all going to tie together. Let's make that a different number. I'll make it easy for myself. In fact, you know what? Don't take notes on this. Just watch. If you want to take notes on this after, you can go watch this YouTube. I really just think sometimes maybe you take too many notes and you don't actually listen to what's being said. You've already done notes on this. Now let's see if we can actually make it to where you can do it. Okay? When I was in geometry, you should have learned that between 2 points, there's only what? There's only one line that connects them. That's in geometry. That's a definition that you should have learned. If you only have one dot, there are infinite amount of lines that go through that. But once I put two dots, there is only one line that goes between those two dots. Yes? So that's why when we're graphing, in order to make a line, guess what you need? You need 2 points. Yes? Well, the problem with slope-intercept form is it doesn't give me 2 points. It gives me a y-intercept. A y-intercept is what? Hello? A y-intercept is a point. So it does give me 1 point. It gives me a specific point, the y-intercept, every single time. So I go on my y-intercept and I go 1, 2, 3, 4, 5. Boom. There's a point. Now, what else do I need in order to draw the line? I need a second point, right? And I sat there and said, it doesn't give you a point, because it doesn't. But it gives you a slope. And a slope legit takes you from 1 point to the next point. That's all a slope does. So if I start at this point, the slope tells me, hey, if you go up 1 and to the right 2, boom, that's your second point, and you can draw your line. That's how hard graphing in linear should be. That's it. Does that make sense now? Now, what did I tell you about 1/2? How else could you rewrite that? Told you another way that you could write. You can always write a slope 2 ways. Nope. Nope. If you put -2 over 1, first off, you've changed the sign. This is a positive. This is a negative number. Those two things will never be equal. Remember, these two things have to be the same. The other thing you did is you made it a 2 over 1. That's value is a 2. This is the half. 2 and a half are not the same. -1 over -2. Why? What happens when you have a negative and a negative? They make it a, and still it's only worth a half. But what does this slope tell me that I can do from this point? Instead of going up and to the right, what's it tell me I can do? Go down 1 and back 2, and boom, you're still on that line. Did that make sense? Questions? So why are you going back to this? Because we're going to graph this. Oops. And you graph this thing just like you do the linear. You are going to go 1, 2, 3, 4, 5. Does everybody see why I went up 5? Does everybody see why I'm going up 1 and over 2? But now I'm going to stop. Because right here, I need to decide something. Here's your decision. Am I going to use a solid line or am I going to use the dashed line? And it's very similar to when we had an open circle versus when we had a closed circle. When did we have an open circle? When it was less than or greater than. When did we have a closed? Was less than or equal to or greater than or equal to. Yes? This one is not equal to. Not equal to's are the dashed line. So when I go to connect these two dots, I'm going to dash my line. Now here's my concept for you that I want you to try to think. Why did I have to dash the line? What is the line? Say it again. The line is where, didn't I graph this? Isn't that what I just graphed? Yes or no? Do you guys get what I mean by that? On my point, if I'm on the line, what do I know about the left side and what do I know about the right side? If I'm on the, let's say I was just drawing this actually. Nope. It's equal to. If I draw this, the left side is always going to be equal to the right side. That's what this line is. What do we know about the left side as it compares to our right side? And it's not allowed to be equal to. Every point on this line will make the left side the same number as the right side every single time. Now it might be different numbers each time. It might be 1 time 10 and this side might be 10. And then I put a different X and Y in and now it's a negative 20 and over here's the negative 20. But every time I put an ordered pair on the line, the left side is going to turn in to the same number as that's on the right side. Do you follow me? And why is that bad for what I'm dealing with? Because the left side has to be bigger than the right side. So how do I tell? Remember, my graph is a visual representation of all the answers. So how do I tell the person, hey, in this one, the line is good. In this one, the line is bad. The way I tell them is I used a solid line to tell them the stuff on the point, on the line, they're good. And I used a dashed one to tell them they're not good. Do you see why we use a dash versus a solid line? Now I'm not finished. The last thing is, for this, one of your sides will be true. Do you see that there are two sides to this line? There's an above it up here. This is a side, and there's a below it. Do you see how the line has two sides to it? One of those sides will be a true side, meaning no matter what you put in, every ordered pair on that side will make this inequality true. And then there's a false side. So either this side is true, every one of these dots over here, every one of these ordered pairs will either make that equation true or false. And this side will be the opposite. So if this is the true side, what do I know about this side? It's the false side. If this is the true side, what do I know about this side? So here's how you do this. You just pick an ordered pair. And you see, does it make the equation, does it make the inequality true or does it make it false? Because if it makes it true, what do I know about the whole side? The whole side is true. If it makes it false, what do I know about the opposite side? So what would be the easiest ordered pair that I could pick? Because I want to make life easy for myself. I'm the person who chooses this crap, so I'm going to set myself up for success. I can use 0, 0. When would be the only time I can't use 0, 0? If the line goes through that, yes? So if I put 0, 0 in, 1/2 0 plus 5 greater than 0, I'm questioning, is that true or not? I'm leaving. Yeah. Costa Rica over spring break, coach. 0 times 1/2 is 0. 0 plus 5 is, so 5 is greater than 0. Is that true or false? True. That means that 0, 0 is on the true side. So what I would do is I would highlight this side over here, and that would tell the person, if you pick any ordered pair, if I picked this ordered pair, what do I know it will do to that inequality? Make it true. What if I pick this ordered pair? What do I know it'll do? What if I pick this one? Do you guys understand how to graph this now?
Wait, so the y always needs 0, but how do you get y?
I picked that. You pick any random order pair that you want. What order pair did I test? And I tested 0, 0 because it's the easiest one. I can pick any order pair. Could I have tried -1,000 and -27 as my X and my Y? Sure. Making life hard on myself. The only time I can't use 0, I use 0, 0 every single time. The only time I told you you can't use it is if that dashed line or solid line goes through the origin, which is 0, 0. Then you cannot use it, and then you use another one. 0, 1, 1, 0, 1, 1, anything that's easy like that. Because you're setting yourself up to be successful. Now, do you remember what I told you today's going to happen? All you're going to do is you're going to do this multiple times on the same graph. Do you follow me? So eventually what's going to happen is I'm going to graph this one, and instead of highlighting, I draw arrows. So let's say I graph it. What do I know since it's a solid line?
It's not equal to.
It was greater than or equal to, or was less than or equal to. I know it was one of those because it was equal to. And what I personally do is instead of shading it when I have multiples, I draw arrows. Do you kind of understand what I mean? Then I would graph my next one completely. So I'd graph the first one. I ignore the other two. I graph the second one, ignoring the second or the first and the third one. Yes? And I graphed my last one. Where do you see the arrows all pointing to? Well, look at this one right here. Do you see this line? I can't be below it, yes? So it has to be above that line. It has to be below this, so it can't be up here. And it has to be below this line. So do you see that area? Oh, I messed up. That area would be all right here. Do you get what I mean?
Oh, so you don't cover it all over.
Well, when we're doing a system, I want the points that work for all three of them. So the only points that work for all three of them would have to fall in this area. That's what we're going to get to eventually. Does that kind of make sense? Now, the problem is, I don't know if we know how to graph like this. What if I asked you to graph this? Does anyone know it? This again is not today's lesson necessarily. This is review. You do not need to do not move this. Yes, you could turn this into slope-intercept form. I want you to learn how to graph this because I think this is actually the easiest one when you learn it. Okay, so we don't know what this one is. Okay, this is called standard form. Each one of the forms is good for something. What was slope-intercept form good for? The y-intercept. Listen to the name. Slope-intercept. It's good for the slope and the y-intercept. Does that make sense? Standard form doesn't tell you what it's good for in its name. You have to know it. So let me talk to you through this. What if we had this? Every single time I'm on the x-axis, what can you guarantee me? We did this at the beginning of the year. Every time you're on the x-axis, you can guarantee me that your y is 0. Every time you're on the x-axis, what can you, or the y-axis, what can you guarantee me? Your x is 0. Does everybody understand that? Okay. Standard form. Remember, how many points do you have to have in order to draw a line? So remember, slope-intercept didn't give me 2 right away, but it gave me a point and a way to get to my other point. Standard form gives you 2 points. It gives you 2 points, but it does not give you a what? It doesn't give you a slope. But if I have 2 points, I can count my rise over my run and find my slope. Do you get what I mean by that? Standard form gives you your x and your y intercepts really fast. What did we say? Every time we're on the x-intercept, what can you guarantee me? What does that mean? This has to do with what we just did. If I now know y is 0, what can you do, guys? What? No. No. What did we just say? No. What did I just do? If y equals 0, what did I do with that, guys? Holy crap. Whenever I know a variable is not a variable anymore, what can I do with that? Thank you. I plugged in 0 for y. As soon as, if I'm trying to find the x-intercept, if I know I'm trying to find the x-intercept, the y is 0. That means I can put y in as 0. It's no longer a variable. What's 2 plus 0? Or 2x plus 0? Divide by 2. Divide by 2. X equals 7. When does x equal 7? That is 1 point. These are, notice I drew a line here. Because the x-intercept is a 7. It's over here. 1, 2, 3, 4, 5, 6, 7. Yes? The y-intercept is somewhere over here, and it's its own point. It's not the same. It's a different point. Cadison, where you at? What can you guarantee me if you know that we are on the y-intercept? What can you guarantee me? And what can we do when we want to find the y-intercept? What can I do to find it? But it's going to be a different thing. Right now it's going to say x or 2 times plus y equals 14. I don't know what the y-intercept is. These are 2 separate things, remember? This turns into a 0, y equals 14. What is that ordered pair? 0, 14. Do you see how I now have 1 point here, which is the x-intercept, a second different point? What do you think kids make a mistake? This is what I see all the time when we do this. They combine them. They are not the same. They are 2 separate concepts. One is the x-intercept, which is a point, and it's over here. Another one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. another point up here, and then once I have 2 points, I can just connect the dots. Yes. The only reason that it was is because that was just a y. I could have done that. When I do this, yes, I do this much faster. I don't have to write it all out because I've done it a bunch of times. So I can go, hey, if I plug in a 0 for y, this is gone. So then that means that x equals 8. So my x-intercept is 8, 0. If I plug in 0 for x, this is gone. So yes, I can go 8, 0 really quickly, and I can also go 12, 0 really quickly. And that's why I was telling you 0, 12, you're right. I can do that really quickly because I understand it. That's why I don't change standard form to slope intercept form, because I can get 2 points like that. And then it's graphed. All I do is go 1, 2, 3, 4, 5, 6, 7, 8, boom, 12, boom, connect the dots. Because you have what? Right. To graph something, you just need 2 points. Slope intercept doesn't give me it. It gives me a point, but it gives me a slope to get to the other point. Standard form gives me 2 points. Is this making sense? Now, today, you're going to just add on to that. Here's what your question's going to say. Whoops. So we're going to do it the same exact way. Do you guys understand what I just said? We just talked about how we graph inequalities. What do? We graph it like it's the line. What do I recognize that this is in? It's in standard form, which gives me x and y. If I put a 0 in for x, that means this is gone. Y is 14, yes? If I put in a 0 for y, 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But then I stop. Why do I stop? I need to decide, is it a solid line or is it a dotted line here? It is a solid line. Next, I need to figure out, am I going to shade above it or below it? What am I going to do that? So I'm going to plug in 0, 0. 2, 0 plus 0. Is that greater than or less than 14? This is a question now. 0 is this. So yes, that is the true side. So if 0, 0 is on the true side, that means this whole side is true. That's how you graph it. Tonight's homework, which I might not give you till Monday, is going to be where you do multiple ones. It's going to look like this. So you would do this one on its own. 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 And then you would draw, like, color in the spot where they all point to. So I personally do not color in on any of these. The book can do it nice and neat because they can do like colors. They can do, this is green, this is yellow, this is pink. And then you can kind of see where the colors are all like, it's a weird color because they're all kind of over each other. You don't have that option because you just have a pencil. So when I draw it, so like this says x has to be greater than or equal to 0. Well, remember, you just graph x equals 0. X equals, and it's a solid line, X equals 0 right here. And where is it going to be greater than 0? All things to the right. Oh, that's Y equals 0. No, this is X equals 0. Yeah. Right. So this one right here would be the Y equals 0, and it has to be greater than that, so it has to be up. Because your Y, it's not that's what it, no one created it like that. That's the name. Look, this is your X, this is your Y. So when your Y is up and down, your Y is up and down. If you're on this, you're moving right and left. You're not moving up and down. That's why your Y is 0. When you're on this line, you're not moving left or right. That's why your X, which is your left and right movement, is 0. It is confusing for kids, but here's how I do it. Remember how if I said your ordered pair was 5, this is when it started to click. If I said ordered pair was 5, you would go on the tick mark, you'd go 1, 2, 3, 4, 5, yes? So if I ask you to graph X equals 5, you do that same exact thing. You just go 1, 2, 3, 4, and when you get to that tick mark, you just draw the whole thing. That is the equation, X equals 5. So if I asked you to graph X equals 0, right? You wouldn't be going anywhere. Boom, that would be your X equals 0. And Y equals 0 would be this one. And so far for this graph, since it's like this, what is the only quadrant that would qualify for both of those so far? So far, it would only be this area right here. Does that make sense? And then what's going to happen is I'm going to have another line that's going to come here, possibly, and maybe another line that's going to come here, and maybe this one goes this way, and this one goes this way, and so it would be this weird shape. Any ordered pair in here would work. Would this ordered pair work right here? Yes, because it's on the line and my line is solid, so that one would work. Do you see how this one was a dashed line? So this ordered pair would not work. This ordered pair that's on this solid line would work. This ordered pair right here on the solid line would work. And any of the points in this area. Does this kind of make sense? You need to look over this. I would watch this YouTube video maybe over the weekend just to remind yourself when you're ready to come in on Monday, because we're going to hammer this out with more of these. There's one more I haven't gone over, which is point slope. I'll go over point slope on Monday.